Hello and welcome to another GCSE Maths Foundation tier walkthrough. And in this video I'm going to go through paper 3, which is the second calculator paper, which you've got coming up. Now I've put the link in the video description to this particular paper so you can follow along at home, and hopefully as I go through it you can have a look at my workings out and maybe you can pick up some tips from how I answer the questions. Now I'm not going to go through all of these instructions, information and advice for the paper because I did that in the last video. So if you do want to pause the video and just have a look at the information here, please feel free to do that. And the last thing just to point out is the foundation tier formulae sheet, which you should be given on your exam. So a lot of these formula you probably already know, but you don't have to memorize them here. You do have them, which you can always refer back to. Okay, so with that all said and done, let's get cracking. So question 1, write 3.84761 correct to 3 decimal places. So first of all, let's write out the number down here. We've got 3.84761. So correct to 3 decimal places. So this is our first decimal place, this is our second decimal place, this is our third decimal place. So if I just draw a line down there just to cut it off. Now we're either going to round it down to 3.847 or we're going to round it up to 3.848. Now in order to determine what we do, we look at the one next to the 7. So we look at the 6 here, and because this is greater than 5, we round this 7 up to an 8. So our answer is going to be 3.848. So if this number is 5 or bigger, we round this number up. If it's less than 5, we would round it down to a 7. Question 2, write 23% as a fraction. So for this, we just need to know what the word percent means. And the word percent means per 100. Let me just write that down. The word percent, okay, cent means 100. So the word cent means 100. If you think about cent in French means 100, century, centurion, centenary, they're all to do with 100 years. So per cent means per 100. So we've got 23 per 100. So that is our answer, 23 over 100. And we can't simplify that anyway, so that is our final answer. Question 3, find the square root of 0.45. Well, we can just pop that into a calculator. We could do this without a calculator, but as we've got a calculator and we're allowed to use one, let's just put it into a calculator. So we're going to type in the square root button and then 0.49, press equals. Now on your calculator, it comes up as a fraction. So you could write 7/10. There's nothing wrong with that. You would get 4 marks. But just because we've got a decimal in our question, let's just give the answer as a decimal. So you just need to press the SD button on your calculator, or you might just be able to see that this is 0.7. Question 4, write down all the factors of 18. So a factor of a number is just a number that goes into another number. So what 2 numbers can we multiply together to get 18? So 18, well, we can have 1 times 18. So 1 and 18 are both factors of 18. How else can we get to 18? What other 2 numbers can we multiply together? Well, 2 is a factor because it's even, and 2 times 9 is 18. Okay, but we're not done there. There are other factors. So the way I like to do this is start off at 1 and then do 2 and now check 3. Does 3 go into 18? And yes, it does. 3 does go into 18 and it goes into 18 6 times. So 3 times 6 is 18. Now we keep going. Does 4 go into 18? Well, 4, 8, 12, 16, and then the next number would be 20, so 4 is not a factor. 5 is not a factor, because it would be 5, 10, 15, 20, and then we're up to 6. Now we already know that 6 is a factor, so we can stop there. So we have all of the factors of 18, so we can just list them out now. So it doesn't matter which order we do it in, but I'll just do it in ascending order, just for the sake of it. So we've got 1, 2, 3, 6, 9 and 18. We have 6 factors of 18. Question 5. Here is a list of fractions. One of these fractions is not equivalent to 2/5. Write down this fraction. So we should have 4 of these fractions that are equivalent to 2/5 and one of them is not. So let's just go through each of these. So 18 out of 45. Now, because this is a calculator test, the simplest way to do this is just to type this fraction into your calculator. And when you do that, it will simplify it for you. So there isn't much brain work involved in this. If you just type in 18 over 45 as a fraction into your calculator, press the equals button, and it will simplify it for you. So when it's fully simplified, we get 2/5. So 18 over 45 is definitely equivalent to 2/5. Now let's do the same one to 14 over 30. So let's just type that into our calculator. Now, I'm being lazy because I could work this out, but I'm just using the fact that it's a calculator exam. And when we simplify this, we get 7 over 15. So 14 over 30 is not equivalent to 2/5. Now we can stop there because in the question it says one of these fractions is not equivalent to 2/5. But let's just keep going just to make sure. So 10 over 25. 10 over 25. And actually for these last ones I'm just going to do it without a calculator because it's not too tricky. So I can see that both numbers are divisible by 5. So 10 divided by 5 is 2. 25 divided by 5 is 5. So 2/5. That works. Now 8 out of 20. 8 out of 20. I can see that both of these numbers are divisible by 4. So 8 divided by 4 is 2. And 20 divided by 4 is 5. So again we get 2/5. That's correct. And the last one, 16 over 40. Both of these numbers are divisible by 8. So that is the highest common factor. So 16 divided by 8 is 2. And 40 divided by 8 is 5. So again, this one is equivalent. Now we could have just stopped here because it only says one of these fractions. But I just thought I'd do all of them just to show you how I would work it out. So our answer, write down the fraction. Our answer is 14 out of 30. Question 6. Sophie spins a fair 4-sided spinner. So we've got a 4-sided spinner here. Each of these sections is the same because it's fair. On the probability scale, mark with an X the probability that the spinner lands on a 2. So to work out the probability that a spinner lands on a 2, well, how many possible ways are there of it landing on a 2? Well, there's 2 possible ways. And how many possible ways are there in total of it landing on a section? Well, there's 4 different sides, so it's 2 out of 4, which is the same as a half. So the probability of it landing on a 2 is a half. So we could just put an X over here. Okay, let's look at part B. Write down the probability that the spinner lands on a 4. Well, there is no 4. It's impossible. You cannot make the spinner land on a 4 no matter how you do it because there are no 4s. So it's a big fat 0. Oh, let's do that in black. You can't quite see that. Big fat 0. Question 7. Write 22 as a percentage of 58. Give your answer correct to the nearest whole number. So what is 22 out of 58 as a percentage? So we can just pop this into a calculator. So 22 out of 58, and yeah, let's just use a calculator. Let's type that in. 22 out of 58. So as a decimal, that gives us 0.379310, and I'm just going to put ... because that number keeps going on and on and on. Now to convert that to a percentage, we just need to multiply that by 100. So if we multiply that by 100, our decimal point now comes here after the 7. So that is going to be equal to 37.9310 ... So that is our answer as a percentage. It says give your answer correct to the nearest whole number. So we've got 37.9. It's either going to stay round down to 37 or it's going to round up to 38. And we can clearly see that because we've got a 9 here, it will round up to 38. So our answer is 38%. Question 8. In a box of chocolates, there are 11 milk chocolates, 5 dark chocolates and 7 white chocolates. Charlie takes one of the chocolates at random. Write down the probability that Charlie takes a white chocolate. So how many chocolates are there to choose from? Well, we've got 11 milk chocolates plus 5 dark chocolates plus 7 white chocolates. That's a total of 23. So 23 chocolates in total. 23 chocks. Now, out of those 23 chocolates, how many are white? Well, there are 7 white. 7 white. So the probability that Charlie takes a white chocolate, well, it's going to be 7 out of 23. 7 out of 23. There's 23 to choose from. Out of those 23, 7 are white. Question 9. There are 1,100 students at school. 540 are girls and the rest are boys. 1/10 of the girls are left-handed and 1/8 of the boys are left-handed. Work out the number of left-handed students in the school. So this is worth 3 marks. So there's a bit of working out to do here. So the first statement, it says there are 1,100 students at the school. So that's the total. 1,100. 540 are girls. So 540 girls. And the rest are boys. So to work out the rest of them, we can just do 1,100 take away 540. That will give us the number of boys. So 1,100 take away 540. That gives us 560. So there are 560 boys. 560 boys. Okay, let's look at the next part of the question. 1/10 of the girls are left-handed. So there are 540 girls and 1/10 of them are left-handed. So we could work out the number of girls that are left-handed by just dividing this by 10. Okay, if we take 1/10 of this, that's the same as dividing it by 10. So let's do that. If we divide 540 by 10, well, we don't need a calculator for that. That would be 54. So there are 54 girls that are left-handed. Okay, now let's look at the boys that are left-handed. 1/8 of the boys are left-handed. So to work out 1/8 of something, we can just divide by 8. We can divide by 8. So 560 divided by 8. Well, I know that 56 divided by 8 is 7, so it's going to be 70. So there are 70 boys that are left-handed. Now, the final question, it says, work out the number of left-handed students in the school. So we just need to add these together. We need to add these numbers together. So 54 plus 70, well, that gives us 124. Question 10. Here is a 3D shape. Write down the name of this 3D shape. Okay, well, it's a prism. I can see it's a prism because if you look at the cross-section, it's got a triangular cross-section and it's got the same cross-section throughout the whole shape. So it's a prism. And what type of prism? Well, I kind of gave it away. It's a triangular prism. So we would say a triangular prism. Okay, part B. Write down the number of edges of this 3D shape. So let's just remind ourselves what an edge is. Well, these are edges. These are edges. So we've got 1, 2, 3. Now let's do the back. We've got another 3 at the back. So 4, 5, 6. And now we've got 7, 8, and 9. So we've got 9 edges in total. Question 11. A shop sells washing powder in 650-gram packs. Jacob has no washing powder. He estimates that he does 2 washes a week using 40 grams for each wash. Jacob wants to buy enough washing powder for 13 weeks. How many packs of washing powder does Jacob need to buy? So again, there's quite a lot of words involved in here and it is worth 3 marks in total. So let's have a look at this part here. So he doesn't have any washing powder to start with. He estimates that he does 2 washes a week and each wash uses 50 grams. So to work out how many grams he needs per week, so grams of washing powder each week. Well, if he does 2 washes per week and each wash uses 40 grams, well, we're just going to do 2 times 40 grams, and that gives us 80 grams. So he needs 80 grams per week. Now he wants to buy enough washing powder for 13 weeks. So total amount of washing powder No, you don't need to write all of these words, but it's just hopefully I'm just trying to explain clearly what I'm doing. So the total amount of washing powder over the 13 weeks, well, it's going to be 80 grams times 13, because we use 80 grams each week and there's 13 weeks. So let's put that into the calculator. So we've got 80 times 13, and that gives us 1040 grams. So that's how much washing powder he needs. So how many packs does he need? Well, each pack is 650 grams. So we can just do 1040 grams divided by 650 grams to tell us the total amount of packs he needs. So 1040 divided by 650, and that gives us 1.6 packs. Now I'm assuming you cannot buy 0.6 of a pack. They sell them in individual packs, so we would have to round that up. So we would round that up to 2 packs. So our answer would be 2. Another way of thinking about this is that if they come in 650 grams, so 650 grams would equal 1 pack. So he clearly needs more than 1 pack. So he would need 2 packs. And let's just check to see how many grams you get in 2 packs. So 650 times 2 would be 1,300 grams. And we can see that that is definitely more than enough for Jacob's needs, washing needs. So our answer is 2 packs. Question 12. Last year, the cost of Tom's train ticket was £42. This year, the cost of Tom's train ticket increased to £50. Write down the increase in the cost of Tom's ticket as a fraction of last year's cost. Okay, so first of all, what is the increase? Well, it's gone from 50 to 42. So we can just do 50 take away 42, which is going to be £8. So it's increased by £8, but the question says write down the increase as a fraction of last year's cost. So it's £8 out of last year's cost, which was 42. Okay, so the fraction that it's increased by 8 over 42. Now it doesn't say to simplify, but we can simplify this. I can see we can half both numbers, so that is 4 out of 21. Yeah, half of 8 is 4, half of 42 is 21. So our answer is 4 out of 21. Question 13. The diagram shows 2 shapes on a centimetre grid. Find the area of shape P. So the area of this triangle. Well, to calculate an area of a triangle, so area of triangle, we do the base times the height, and then we divide by 2. So the base is 4 units, or 4 centimetres, because it's on a centimetre grid. The height, well, the height is going to be 1, 2, 3, 4, 5, 6. So we're going to do 4 times 6 and then divide by 2. So 4 times 6 is 24. Half of 24 is 12. Our answer is 12, and it's already got centimetres squared, so we don't need to write that in. Okay, and part B, write down the mathematical name for shape Q. Well, the name of this shape is, well, to understand what the name is, we need to see that here we've got parallel sides. These 2 lengths are parallel, and these 2 lengths are parallel, or these 2 sides are parallel. So any shape with 2 pairs of parallel lines is a parallelogram. Parallelogram, and I think I've spelled that correctly. So don't worry if you don't get to spell it correctly, but it is a parallelogram. If these four sides were also the same length, then it would be a special type of parallelogram, which would be a rhombus, but we can clearly see that these are different lengths. So this length here is different to this length. So it's just a bog standard parallelogram. Question 14a, find the value of 30.5 squared plus 12.1 squared. Now, so this is just testing your calculator skills. So you're just going to type into the calculator 30.5 and then the squared button, and then plus 12.1 and then the squared button again. Press equals. Now the answer usually comes up as a fraction. It depends how your calculator is programmed, but if it's just set up and you haven't changed any settings, it will come up as a fraction. So it comes up on my calculator as 53,833 over 50. But then if you press the SD button, it comes up as a decimal, which is 1076.66. So this is the answer. I'm not sure whether you'd get a mark for this, possibly, because this is correct, but you should write your answer for this as a decimal. Now, if we do part B of the question, a lot of people do go wrong on this question, this type of question. So let's just clear everything. So on our calculator, we're taking the square root of this sum here, not this part. This is separate. So you're going to type in the square root of 5.13 plus 10.28. And then you could, there's two things you could do. You could press equals, and then, so whatever this is, get your answer, and then press minus 0.97. So do it in two stages. So this is stage 1, this is stage 2. So work out the answer to this, and then take away 0.97. And that gives us 2.95555. You should write down all of the numbers on your calculator to display for this. 7285. Okay. The other way to do this would be to do it all in one go, but that's where a lot of people make a mistake. A lot of people, if I just show you what a lot of people do, they'll type in the square root button on their calculator. They'll do 5.13 plus 10.28, and they'll forget to press the right arrow button to get out of the square root. So if you don't press the right arrow button and just press minus 0.97, what it will do is it will take the square root of that whole thing, which is obviously completely incorrect. Okay, so just make sure you split it up. So the only thing that's being square rooted is this first sum here. Question 15. AB and CD are parallel lines. So these two lines are parallel, which we can see because of the arrows. An angle of 110 degrees is shown on the diagram. Write down the letter of one of the other angles of size 110. So there are a few other angles on this diagram that are 110. We only need to write down one of them. And I can see that if this angle is 110, this angle here is also 110 degrees. So our answer, one of our answers, is B. Now the other answers you could have put, I'll go through that in a moment actually. Let's just go through part B. It says give a reason for your answer. So you need to provide a mathematical reason for why B is also 110. And the reason is because vertically opposite angles are equal. So vertically opposite angles are equal. Okay, you could also just put opposite angles are equal. That should also give you the mark. Let's just go through some of the other angles that are also 110. So you could have also said F. So F would also be 110. And the reason for that is because these two angles here, so these two angles have a special relationship, and they are called corresponding angles. Corresponding. So corresponding angles are also equal. So F would work. D would also work, and D would work for the same reasons as B. You can see that these two angles are also vertically opposite, so D would also be 110 degrees. And the other one that is 110 degrees, well, not the other one, you could have also given a different reason for D. So D we know is 110, and these two angles have a special relationship. So these two angles here are called alternate angles. Alternate angles. So you could have either said B, D, or F, and one of the three reasons. So either corresponding angles, alternate angles, or vertically opposite angles. But you need to make sure you give the right reason for the right angle. So if you'd said F because they are alternate, then you would not get a mark. You have to give the right reason for the right angle. Question 16. The accurate scale drawing shows the positions of two towns, A and B, and we're also told that 2 centimeters on our map represents 1 kilometer in real life. Part A, find the real distance between town A and town B. Now for this particular question, it's going to be hard for you, or you probably won't be able to do this because it is on the screen. Fortunately for me, I've printed this paper out. So the first thing I'm going to do is I'm going to measure the distance from A to B on my piece of paper, and then I'm going to use the scale, or the relationship between centimeters and kilometers on my scale to work out the real distance. So I've just measured this distance here, and I make it out to be 4.8 centimeters on my piece of paper. So we know the scale is 2 centimeters equals 1 kilometer. So I can see that I just need to half my number. So 4.8 centimeters. Well, if I just half this number here, that will give me 2.4 kilometers. So my answer is going to be 2.4 kilometers. And there is some slight margin for error on this, but you need to try and be as accurate as possible. Okay, now part B. Town C, which is not on the map, is 3.2 kilometers from B. So it's 3.2 kilometers from town B, and it's on a bearing of 255 degrees. So let's just highlight that. So it's 3.2 kilometers from B, and it's on a bearing of 255 degrees. Draw the position of C, of town C, with a cross on the diagram. Now again, just like part A, you won't be able to do this because you don't have the sheet of paper. If you did want to print it off, then please feel free to do that. So what I'm going to do, the first thing I'm going to do is I'm going to measure a bearing of 255 degrees from town B. So town B is here. Now we always go from north, so we always measure from north. So I'm going to measure 255 degrees from this point here. Okay, well let's do that in red actually, just to make it clear. So we're going to start here. We're going to go all the way around until we get to 255 degrees. Now I know that this is 270 degrees, so it's going to be somewhere approximately here. Okay, so our bearing, we're going to go all the way around until we get to 255 degrees, and we're going to measure the distance. Now we need to work out what the distance is on the piece of paper. We know the distance in real life is 3.2 kilometers. So we've got our scale here. So 3.2 kilometers. Well, to go from this number to this number, we just multiply by 2. So we're going to times this by 2. So it's going to be 6.4 centimeters. So we're going to measure 6.4 centimeters. And it's going to be on this bearing here. So let's say that this here is 255 degrees. So it's going to be on this bearing here. Now this is obviously not to scale. Actually, I could probably do a bit better than that. Let's just delete what I've just done. I'd say it's probably more like this on this bearing here. And it's going to be 6.4 centimeters, so slightly longer than this distance. So let's say it's about here. Okay, so this will be point C. So this angle here, this angle is 255 degrees, and this length that I've measured is 6.4 centimeters. So this is point C. And it does say mark with a cross on the diagram. So let's just change that to a cross. That is point C. Question 17. A car is travelling at a speed of 120 kilometers per hour. Find the speed of the car in meters per second. So we know our car is travelling at 120 kilometers per hour. Let's just write hour down. So let's first of all convert the kilometers into meters. So how far is 120 kilometers? Well, to convert from kilometers to meters, what do we need to do? Well, we need to multiply by 1,000. There are 1,000 meters in a kilometer. So we need to multiply this by 1,000. So 120 times 1,000, we just need to add 3 zeros on the end. Okay, so it's going to be 120,000 meters per hour. So now we've got the speed in meters per hour. We've done half of it because we want meters per second. So we just need to change the hours into seconds. Now I'm going to go from hours to minutes first and then minutes to seconds. So I'm going to do it in two parts. So if we're traveling 120,000 meters in 1 hour, how far will we be traveling in 1 minute? Well, there's 60 minutes in an hour, so it will be 60 times shorter. So we just need to divide this by 60. So we just need to do 120,000 divided by 60, which is going to be, I think that's 2,000. Yeah, 2,000. So our speed in meters per minute is going to be 2,000. 2,000 meters per minute. Okay, so we've gone from meters per hour to meters per minute. Now we need to go to meters per second. So if we travel 2,000 meters in a minute, how far will we travel in a second? Well, it's going to be, again, 60 times less because there are 60 seconds in a minute. So we just need to divide this by 60 again. So we need to do 2,000 divided by 60. And I'm not quite sure what this is, so let's put this into a calculator. 2,000 divided by 60. That gives us 33.3 recurring. So if we just round that to one decimal place, it's going to be 33.3. And now that is in, if we just write that out in full, so 33.3. Now our answer is in meters per second, which is what we were asked for. So our answer is 33.3. Question 18. ABC is a straight line, which is this line here. Show that ABD, so ABD, that's this triangle, is an isosceles triangle. So what do we mean by an isosceles triangle? Well, an isosceles triangle is a triangle where two of the angles are the same or two side lengths are the same. So we're not given anything about the side length, so let's try and prove that two of these angles are the same. So what can we do? Well, we're told that this is a straight line, so we can work out what this angle is because we know that angles on a straight line add up to 180 degrees. So we can say that angle ABD, and that's how we denote that angle. So the angle in the middle is always the one we're looking for. We're looking at angle B here. So we would write it ABD, or you could write DBA. That would still be this angle. So this angle here, well, it's going to be 180 degrees minus 124 degrees. So if we work that out, that's going to be 56 degrees. So this angle is going to be 56 degrees. Now, one really important thing to mention is whenever you say an angle, what the size of an angle is, you have to say y. So the reason that this is 56 degrees is because I use the fact that angles on a straight line add up to 180 degrees. So I have to write that down. So angles on a straight line sum to 180 degrees. That's really important that you write that down. If you don't write the reason down, you will lose marks. Okay, so now we've found that this angle is 56 degrees. We've got two angles in a triangle. We can work out this missing angle. So angle DAB, or angle DAB, well, that's going to be So we add these two together and take that away from 180 degrees. So it'll be 180 degrees, take away the sum of these two angles. So 68 degrees plus 56 degrees. So let's just put that into a calculator. So 68 plus 56, and then we take that away from 180, we get 56. So that gives us 56 degrees, which we can put in there. And we can see that it is isosceles, because these two angles are the same. Now, before we write anything down, we need to give our reason for what we've just worked out here. So this is 56 degrees, and the reason for that is because angles in a triangle sum to 180 degrees. So angles in a triangle sum to 180 degrees. So we've given our got our two angles, and we've given our two reasons. Now we just need to write a concluding statement. So we can say that ABD, so triangle ABD is isosceles because two of the angles are congruent. Two of the angles are congruent, or you could write just the same. Congruent, just put in brackets, the same. Okay, so we've got our two angles, our two reasons, and then just a concluding statement to say, just to show that this triangle is isosceles because these two angles are the same. Question 19a. Factorise fully 30x cubed plus 12x. So we need to factorise it fully. So we need to find the highest common factor of these two terms. So if we first think about the numbers, what's the highest common factor of 30 and 12? So the largest number that goes into both of these is 6. So let's just write that down. The highest common factor of 30 and 12 is 6. So we can factor out a 6. And now let's think about the variables, x cubed and x. And the highest common factor of x cubed and x, well, that's just x. So I'll write that down. So the highest common factor of x cubed and x is just x. So we can factor out a 6x from our expression. So our answer is definitely going to start with 6x, and then we'll put our brackets in. And now we need to work out what's going to go inside our brackets. So we need to divide each term by 6x. So if we divide 30x cubed by 6x, well, 30 divided by 6 is 5, and x cubed divided by x is x squared. And now we've got plus, and now we just need to divide this term by 6x. So 12 divided by 6 is 2, and x divided by x, well, those two x's will just cancel out, so it's just 2. So our final answer is 6x, and then in brackets 5x squared plus 2. Okay, let's look at the next part. Part B, solve this equation. So we've got 5f minus 2 equals 22. So first thing I'm going to do is I'm going to expand the brackets. So I'm going to do 5 times f, which gives me 5f. And then 5 times negative 2 is negative 10. And then that equals 22. So that's our first part. And now we want to get f on its own. So let's get rid of this negative 10. So if we add 10 to both sides, that will get rid of this negative 10. So we'll be left with 5f equals 22 plus 10 is 32. And now we can divide both sides by 5. So if we divide both sides by 5, so we are left with f equals 32 over 5. So our answer is 32 over 5. Let's just write that as a decimal. 32 divided by 5. As a decimal, that is the same as 6.4. So 6.4. These two things are the same. It doesn't matter which answer you put. So you could write it as a fraction or as a decimal. Either way, you'll both get full mark. You'll get 4 marks for either way. Question 20. Light A flashes every 8 seconds. And light B flashes every 20 seconds. Both lights flash at the same time. Work out how long it will take for both lights to flash at the same time again. So there's a few ways we could do this. Essentially what we're looking to try and find is the lowest common multiple of 8 and 20. Okay, so if we think about light A, so that flashes every 8 seconds. So if we think of the times that it will flash after 8 seconds, it will flash after 16 seconds, it will flash after 24 seconds. All I'm doing is the 8 times table. So then it will be 32, 40, 48, 56, 72, 80, and so on. So I don't know how far we need to go. But now let's look at light B. Light B. So that flashes every 20 seconds. So after the first flash, it will then flash after 20 seconds, and then after 40 seconds. Now, I don't need to go any further. The reason I don't need to go any further is because I can see that after 40 seconds, they both flash. So they both flash after 40 seconds, and that's the first time they flash. So how long will it take for both lights to flash at the same time again? Well, it takes 40 seconds. So it takes 40 seconds. So we had to calculate the lowest common multiple of 8 and 20, which is 40. I did it by listing, but there are other ways you could do it. The reason I did it by listing is because these numbers aren't very big. So it didn't take long for me to work out that the 40 was the answer. Question 21. Here are the times in seconds it took 15 boys to complete a puzzle. So 45 seconds, 32 seconds, etc. Work out the median. So the median is just the middle time. So the median is the middle time, or the middle number. So what we'll need to do is we'll need to put these in order and then find the middle number. Now, there's a few ways you could do this. You could do a stem and leaf diagram, but I think what I'm going to do is we don't have that many numbers, so I'm just going to go through all of them and try and put them in order as I go. So I can see that there's nothing less than 30. So if we have a look at all of the ones that are 30, we've got 32, 35, 33 and 36. So if we put those in order, we've got 32, 33, 35 and 36. Now let's look at all of the 40s. We've got 40, 42, 47, 43, 44 and 45. So the smallest is 40. And then we've got 42, 43, 44, 45, 47. So 42, 43, 44, 45 and 47. And now let's do all of the 50s. We've got 52, 59, 58, 54 and 54. So 52 is the smallest out of those. And then we've got two 54s. So 54, 54. And then 58 and 59. 58 and 59. So let's just make sure we've got 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we do have 15. So the median, what time is the median going to be? Well, it's going to be the middle number. And to work out what the middle number is, there's 15 boys. So we can just do 15. We add 1 and then we half it. So 15 plus 1 is 16. Half of 16 is 8. So it's going to be the 8th time, the 8th quickest time. So 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 44. Now we need to write down in seconds, so it's 44 seconds. Okay, now let's look at part B. Work out the range. The range just means what is the difference between the quickest time and the slowest time. So the quickest time was 32, the slowest time was 59. So we're going to do 59 take away 32, which gives us 27. So our answer is going to be 27 seconds. Okay, let's look at part C now. 15 girls also completed the puzzle. The table below shows information about the times in seconds it took 15 girls to complete the puzzle. So the quickest time was 30, which looks like it's quicker than the boys' time. and the greatest time was 58, which looks like it's also quicker than the boys' time. But the median is 47, which is slower than the boys' time. So part C, it says compare the distribution of times of the girls with the distribution of times of the boys. So whenever you're asked to compare the distribution, they're always looking for two things. They're looking for the spread. So they're looking for the spread of data. Okay, so how spread out the data is. And the second thing they're looking for is the average. Okay, the average. And in this case, the only average we've got for the girls is the median. Okay, so we're going to have to use the median. So we're going to compare the spread of the data, how spread out the data is. And for that, we would use the range. And we're also going to compare the averages. And for that, we're going to use the median. Well, in terms of the average, I can see that the boys were quicker than the girls. So let's write that down. So boys faster than girls on average. And then we need to write down the values. So in brackets, 44 seconds versus 47 seconds for the median. And so we've done the average. Now we need to look at how spread out the data is. So the range. So we know the range for the boys is 27 seconds. Let's look at the girls' range. So the range for the girls, or the greatest time is 58. The quickest time was 30. So 58 minus 30 is 28. So it's close, but it looks like the girls have a slightly larger range. So girls, we could say the girls' times vary more than boys. And let's just give our data for that. So 28 seconds versus 27 seconds for the range. Okay, and it's not on this page here. I've cut it off, but this last part is worth 3 marks. So you need to make sure that you compare the distribution of compare the ranges, compare the medians, and make sure you give your mathematical, your numerical values to back that up. Question 22. The frequency table shows the heights in centimeters of some tomato plants. So it looks like we've got 7 tomato plants that have a height of between 140 and 150 centimeters, and so on. Draw a frequency polygon to show this information. So a frequency polygon is almost like a line chart. So what you do is, first of all, we'll plot the points, and then we'll connect those points with a straight line. So there are 7 tomato plants that have a height between 140 and 150. So what we do is we use the midpoint. So we're going to look at 145 centimeters, and we're going to go up to 7. Now it looks like here we've got 10 small squares. I'm going to write this down. We've got 10 small squares, which equals 5 plants. So we're going from 5 to 10. So 5 plants. So it's not quite a one-to-one relationship on our axis. So therefore, 1 plant. So every plant is going to be 2 small squares. So every plant is going to be 2 small squares. So 7. So that's going to be 6, and that's going to be 7. I know it's quite hard to see because it's quite a small. It's quite a small diagram, but we're going to go from 145 up to 7, which is here. So you want to get it on that point there. Now let's look at the next row. So we've got 10 tomato plants that are between 150 and 160 centimeters. So again, we pick the midpoint, which is 155, and we go up to 10. That one's a bit nice, and that's nice and easy because that's on a thick line there. Now the next one, 15, and we're going to go take the midpoint, so 165 up to 15, which is here. The next one, we're going to take 175 for the midpoint, and we're going to go up to 19. So that's 20, so it's going to be 2 squares below 20. And the last one, we're going to go along to 185 and up to 9. So this is 10, so it's going to be 2 squares below 10, which is here. Now, that's the first part. The second part is to connect them with a straight line. So we're going to start here. We're going to draw a line from here to here. And we're going to do the same up to here. Just keep going. And you need to use a ruler for this. I'm using my line tool, but you need to use a ruler. And then down to this last one here. So this is our frequency polygon. Now you won't get deducted any marks if you start in the bottom corner here. Some people start from the origin and go up to the first point. You won't lose any marks for that, but you should just keep it like this because we don't have any information about anything below 140. Question 23, Banana Computers, strange name for a company, but we'll go with it. Banana Computers sold 19.3 million computers in 2017. And in 2018, they sold 18.2 million computers. They're not doing as well the following year. Work out the percentage decrease in the number of computers sold. Give your answer to 3 significant figures. So let's first of all work out what the decrease was as a number. So how many computers less did they sell in 2018 compared with 2017? So we just need to do 19.3 million. So it's going to be 19,300,000. Take away 18,200,000. So this will be the number of computers less they sold. So let's just work out what that is. So we've got a 1 here, 1 here, that's a 0. So 1,100,000. Okay, so that's how many less computers were sold. It says work out the percentage decrease, not the decrease in total, the percentage decrease. So to work out the percentage decrease, we need to take the actual decrease, so 1,100,000, and we need to divide that by the original amount of computers were sold. So from the original amount, so 19.3 million. So 19,300,000. And then just to pop that into a percentage, we need to multiply that by 100, because at the moment this will give us a decimal. So to express it as a percentage, we need to multiply by 100. Right, so after putting all of that into a calculator, I get the answer of 5.69948. I'm just going to write down everything on my calculator to display. 1865, and that is percent. So it's just over 5% decrease. Now in the last line it says give your answer to 3 significant figures. So 3 significant figures. This is our first significant figure. So 1, 2, 3. So we're going to have to look at this 9 here. So we're going to either round this up or it's going to stay at a 9. And we can see that this 9 tells us that we're going to round this up. So it's going to round up to 5.70. So our answer as a percentage is going to be 5.70%. Question 24. The value of a house increased by 6%. The house then had a value of £265,000. Work out the value of the house before the increase. So this is where a lot of people do struggle with. It's reverse percentages. So we're told the value of the house after the increase. So always think about the original price. So the original price representing 100%. So whatever the original price was, that's always 100%. So the value of the house increased by 6%. So if the house was originally 100% and now it's increased by 6%, the value of the house now is going to be 106% of the original price. Okay, so the value of the house represents 106%, and that corresponds to a value of £265,000. So the price of the house costs £265,000, and that represents 106% of the original price. So we want to work out the value of the house before the increase. So we want to work out how much it costs at the original price at 100%. So we need to go from 106% to 100%. So how are we going to work out this price? Well, we could work out what 1% is first. That's what I usually do. So if we know what 106% is, we can work out what 1% is by just dividing by 106. So if we divide the value by 106, that will tell us what 1% is. So 265,000 divided by 106. That gives us, that was a nice round number, £2,500. So that's what 1% is. So to work out 100%, we just need to multiply that by 100. We need to multiply it by 100, and I don't need a calculator for that. So it's going to be 2500, and then we're going to add 2 zeros on the end. So our answer is going to be £250,000. Now you can check your answer by going the other way. So if it was £250,000 and it increased by 6%, well, you could do 250,000 times 6% increase, or 1.06. And if you do that, you should get back to the new price of £265,000. So you know whether you've got the answer correct or not. Question 25. We've got the formula S equals UT plus half AT squared. And we're given the values for U, A and T. And it says work out the value of S. So we want to work out the value of S when we substitute these numbers for U, A and T into our formula. So let's do that. So we know S is going to be U, which is -5, multiplied by T, which is 3. And then we're going to add on a half times A, or A is 4, and then multiply it by T squared. So 3 squared. We're going to multiply that by 3 squared. So all I need to do is pop all of this into a calculator. So we've got -5 times 3 plus a half times 4 times 9. And we get 3 as our answer. So our answer for this, S equals 3. Part B, make A the subject of this formula. So at the moment, S is the subject. We've got S equals. We have to rearrange this formula so that it says A equals. So that's what it means to make something the subject. It means to put it on its own. So we want to get A on its own. So at the moment, we've got this UT on this side of our equation. So if we get rid of UT, I'm going to subtract UT from both sides. So I'm just going to write out the formula again, just so it's a bit bigger. So S equals UT plus half AT squared. So the first thing I'm going to do is I'm going to subtract UT from both sides. So if I do that, I'm left with S minus UT on the left hand side equals, so all I've got is this bit now. So all I've got is a half AT squared. Okay, now again, we want to get A the subject. So at the moment we've got half here. So to get rid of that half, well, I can just multiply both sides by 2. If I multiply this side by 2, 2 times a half is 1. So it will just get rid of this half. So if I multiply both sides of my equation by 2, what am I left with? So I'm going to multiply this whole thing by 2. So I could write it out like this. 2 and then in brackets S minus UT. You could expand the bracket, so you could write 2S minus 2T, but we don't need to. I'm just going to write the 2 outside of the brackets. And then equals, well, a half times 2 is 1, so that just gets rid of that half. So all we're left with is AT squared. So we're getting closer now. Now the last step is we want to get rid of this T squared because we want A on its own. So at the moment we're multiplying by T squared. So to get rid of that, we can just divide by t squared. So if we divide both sides by t squared, I'm running out of room, so I'll put it over here. So on the left hand side, well, we've got 2 and then in brackets s minus ut, and then all of that over t squared. And on the right hand side, well, all of this divided by t squared, we're just left with a. So we have made a the subject. So our answer, it doesn't matter which way round we put it. If we put the a on the left, we could write a equals 2 lots of s minus ut and all of that over t squared. Question 26. There are 120 people in a school canteen. 40% of the people in the canteen are year 11 students. The number of year 11 students in the canteen is 3 times the number of year 10 students. The rest of the people in the canteen are year 9 students. And now it tells us the number of year 9 students to the number of year 10 students is n to 1. Work out the value of n and you must show how you get your answer. So it's quite wordy. This is only worth 2 marks, this one, but there's quite a lot involved here. So let's go through this step by step. So there are 120 people in the canteen and 40% of the people are year 11s. So to work out the number of year 11 students, so year 11, well, we're just going to do 120, but we're going to take 40% of 120. So we can just do 120 multiplied by 0.4. And I don't think I need a calculator for that. I think that is going to be 48. So you could use a calculator. There's no reason why you shouldn't. But I think I can do that in my head. So there are 48 year 11 students. Now it says the number of year 11 students is 3 times the number of year 10 students. So the number of year 10 students, well, it's going to be 3 times less than 48. So it's going to be 48 divided by 3. And I can do that as well in my head, is 16. So there are 16 year 10 students and 48 year 11 students. And now it says the rest of the people in the canteen are year 9 students. So we know that there are 120 people in total. 48 are year 11, 16 are year 10, and the rest are year 9. So we can just add these together and take it away from 120. So 120 take away 48 plus 16. So 48 plus 16 is 64. And if we take that away from 180, that will leave us with 56. I'll just put that into a calculator just to double check. So 120 minus 48 plus 16. And yes, it does give us 56. So there are 56 year 9 students. Now we have to write down the ratio. So the ratio of the number of year 9 students, so year 9 students, to the number of year 10 students. So there are 56 year 9 students and there are 16 year 10 students. Now we have to write that as a ratio n to 1. So something to 1. Well, to go from 16 to 1, we're just going to divide by 16. So we have to do exactly the same to this number. We need to divide 56 by 16. So let's do that. 56 divided by 16. And that gives us 3.5. 3.5. So the ratio is 3.5 to 1. So work out the value of n. Well, the value of n is 3.5. And we've got all of our workings out here. Question 27. Amy drives 300 miles from London to Newcastle. She drives the first 165 miles at an average speed of 60 miles per hour. From this point, it takes Amy 3 hours and 5 minutes to complete her journey. What was Amy's average speed for the whole journey? Give your answer correct to 3 significant figures. Right, so she drives from London to Newcastle. So let's just do a small diagram here. So we've got London and Newcastle. And the distance between the 2 towns, or cities I should say, is 300 miles. 300 miles. So she drives the first 165 miles at an average speed of 60 miles per hour. So let's work out how long it takes for Amy to travel the first 165 miles. So we know the formula for speed, distance and time. So I always like to represent it like this as a triangle. So we know that speed is distance divided by time. If we wanted to calculate the distance, we would do the speed multiplied by the time. And if we want to calculate the time, we'd do the distance divided by the speed. And that's what we're going to do. So the time, and this is only the time for the first 165 miles, not for the whole journey. So the time, I'm just going to put a little 1 here just to show that this is the first part of the journey. So it's going to be the distance, which is 165 miles, divided by the speed, which is 60 miles per hour. So let's get our calculator out. So 165 divided by 60, and that gives us 2.75. 2.75, and our units will be in hours. So that is hours. Right, so let's have a look at the next point. Now it says from this point, it takes Amy 3 hours and 5 minutes to complete her journey. So we can work out the total time. So total time just by adding these two numbers together. So we've got 2.7 hours, 2.75 hours. And if we convert that to hours and minutes, well, that is the same as 2 hours and 45 minutes. And the reason why I knew it was 45 minutes is because this is 3/4 of an hour. So 0.75 is 3/4. So it's 3/4 of an hour, which is the same as 45 minutes. So 2.75 hours is 2 hours and 45 minutes. So it's going to be 2 hours 45 minutes plus 3 hours and 5 minutes. 3 hours and 5 minutes. So we just need to add these two together. So that's going to give us 5 hours and 50 minutes. 5 hours and 50 minutes. Right, so we've got the total time. We know the total distance. The total distance, I'll write that down. Total distance is 300, where is it? 300 miles. So now we are able to calculate the average speed. So the average speed is going to be the total distance divided by the total time. Now we're going to have to put the time in hours. So we're going to have to convert 3 hours and 50 minutes just in hours. So it's going to be 5 and 50 minutes out of 60. Well, that's 5/6. So it's 5 and 5/6 hours. 5 and 5/6 hours. We've got 5 hours and 5/6 of it. 5/6. Hard to say. 5/6 of an hour. Or if we wanted to write that as an improper fraction, well, 5 times 6 is 30. 30 plus 5 is 35. So it'd be 35 over 6 hours. Okay, so now it doesn't really matter how we do this because we do have a calculator. If we didn't have a calculator, it would be probably easier to leave it as an improper fraction. But we do have a calculator, so it makes things a lot easier for us. So the average speed, I'm just going to put av speed. Well, that is going to be the total distance, which is 300, divided by the total time, which is, well, either one of these. Let's use this one here, so 35 over 6. So let's just pop that into a calculator. So 300 divided by 35 over 6, and we get 51.42, write this down, 51.42857, and that just keeps going on and on. But it asks us to give our answer to 3 significant figures, so it's going to be 51.4. We're going to round down because the 2 tells us to round down. It's going to be 51.4 miles per hour. Question 28. Potatoes cost £9 for a 12.5 kilogram bag at a farm shop. The same type of potatoes cost £1.83 for a 2.5 kilogram bag at a supermarket. Where are the potatoes better value? At the farm shop or the supermarket, you must show your working. So it's £9 for a 12.5 kilogram bag. Let's write that down. So £9 for a 12.5 kilogram bag. Or £1.83 for a 2.5 kilogram bag. So let's think about the 2.5 kilogram bag. So it's £1.83 for a 2.5 kilogram bag. If we equate the mass of each packet of potatoes, let's work out how much it would cost from the supermarket if we were to get 12.5 kilograms. So if we were to get 12.5 kilograms from the supermarket, how much would it cost? Well, to go from 2.5 to 12.5, we are multiplying by 5. And you can check that with a calculator. If you did 12.5 divided by 2.5, we would get 5. So we're buying 5 times as much. So it's going to cost 5 times as much. So now if we do 1.83 times 5, that gives us £9.15. £9.15. So for the same amount of potatoes, it's cheaper at the farm shop. So we need to say that. We need to give our answer of the farm shop, and then you could just, but we need to just say why, because £9 is less than £9.15. It's quite obvious, but let's just conclude by saying that to buy 12.5 kilograms from the farm shop is £9, and that is less than if we were to buy it from the supermarket. Question 29. ABCD is a trapezium. Calculate the area of the trapezium. Now, there are a couple of ways we could do this. We could calculate the area of the trapezium outright, if you know the formula for the area of the trapezium, or we could break it down into a rectangle and a triangle. So what I'm doing is I'm drawing a horizontal line that is perpendicular to line AD. So because it's perpendicular, we've got a right angle here. So we can calculate the area of this rectangle, then calculate the area of the triangle, and then add the two together. So first of all, let's calculate the area of the rectangle. So our length is 15, but notice we're not told what our height is. So this length here, we don't know what this is. We're going to have to work it out. And to do that, we are going to use Pythagoras' theorem, because I can see we've got a right angle triangle here. We know the hypotenuse is 17 centimeters, and we know this length is 15 centimeters because it's exactly the same as this length. So we can use that to calculate this length here. Okay, and once we know this length, we'll then be able to use that to work out this length in blue. So how are we going to calculate this length here? Let's just label it x for now. So we're going to use Pythagoras' theorem. So Pythagoras' theorem states that x squared plus this squared, so 15 squared, is equal to our hypotenuse squared. So we square both of the shorter sides, add them together, and that is equal to the hypotenuse squared. So what is 15 squared and 17 squared? So we've got x squared plus this. Well, 15 squared is 225, and 17 squared is 289. So now to get x squared on its own, if we take away 225 from both sides, so I'm just taking away 225 from both sides. So what are we left with? Well, we're left with x squared is equal to 64. And now if we square root both sides, we are left with x equal to, it would be positive or negative 8, but we can't have negative lengths, so it is just 8. So x is 8 centimeters. Okay. Now we know this whole length is 12 centimeters, so if x is 8, this length in blue, well, that's just going to be 4 centimeters, because we do 12 minus 8. Now we have all of the dimensions, we can calculate the areas. So this area here is going to be 15 times 4, which is 60 centimeters squared. And now the area of the triangle, we do the base times the height and then divide by 2. So the base, this is our base because it's just the triangle is just being rotated. Or you could think about this as the base. It doesn't really matter which way round we think about it. It's just going to be 15 times 8 divided by 2. So 8 divided by 2 is 4. 4 times 15 is 60. So that is also going to be 60 centimeters squared. It might not look 60, but remember, the drawings are not drawn to scale. Okay, so this is definitely 60 centimeters squared. So the total area is just going to be 60 centimeters squared plus another 60 centimeters squared, which gives us 120 centimeters squared. So let's put that in our answer. We don't need to write centimeters squared because it's already given to us. So there's quite a lot of working out to do, which is why this question was worth 4 marks. Question 30. The diagram shows a rectangle and a triangle. The perimeter of the rectangle is equal to the perimeter of the triangle. So the perimeters of both shapes are exactly the same. Find the value of x. Right, so we're told what the base and the height is of the rectangle. So this height over here, well, that's going to be exactly the same as this height. These two lengths are the same. So this is going to be x minus 5. And likewise, this length is going to be the same as this length. So this is also going to be 2x plus 7. And we're given all of the lengths for the triangle. So the perimeter is the total distance around a shape. So the perimeter, let's just write peri for the rectangle. I'm just using shorthand here. So the perimeter for the rectangle, we're going to add up all of these lengths. So it's going to be x minus 5 plus x minus 5 plus 2x plus 7 plus 2x plus 7. So we can simplify this a bit. If we collect all of our x terms, we've got x plus 2x plus another 2x. That's 2, 4, 5, 6x. So it's going to be 6x. Now if we add together all of our numbers, we've got minus 5 minus another 5. That's minus 10 plus 7. Well, I think we're now at minus 3. And then plus another 7. Now we're at positive 4. Or an easier way to think about it is 7 plus 7 is 14. 14 take away 5 is 9. Take away another 5, we're left with 4. So it is 6x plus 4. And now let's do the perimeter for the triangle. Okay, so again, we're going to add up all of the side lengths. So we've got x plus 2x plus 2x plus 11. Okay, and we can simplify that. So just like I did before, if we add up all of the x terms, so we've got x plus 2x plus another 2x, that gives us 5x. Gives us 5x, and then we've just got plus 11. Okay, so we've written an expression for the perimeter of both shapes. And now here it says the perimeter of the rectangle is equal to the perimeter of the triangle. So these two things must be equal. So we can write an equation to set them equal to one another. So 6x plus 4 must be equal to 5x plus 11. And now we can just solve this equation. So if we take away 5x from both sides, I'm putting all of the x's on the left hand side. Now we're now left with x plus 4 equals 11. And now if we subtract 4 from both sides, so if we take away 4 from both sides, well, that leaves us with x being equal to 11 minus 4 is 7. So find the value of x. X is 7. And you can double check your answer. What you could do is you could substitute 7 into your expressions to work out the perimeters of both shapes. And if you do that, you should get the same perimeter for both shapes. So we have finally reached the last question of the paper, question 31. Here are the first 5 terms of a sequence. Find an expression in terms of n for the nth term of the sequence. So the first thing I'm going to do is just write down the sequence again. So 9, 14, 19, 24 and 29. Now, in order to work out the nth term, the first thing we have to do is work out what the difference is between terms. So it looks like we're adding on something each time. So to go from 9 to 14, we are adding on 5. Go from 14 to 19, we're also adding on 5. Go from 19 to 24, we're adding on 5. And to go from 24 to 29, we are also adding on 5. So because we're adding on 5 each time, the nth term is going to start with 5n. So you could think about this as this sequence is similar to our 5 times tables because we're going up by 5 each time, but each number is slightly adjusted from our 5 times table. So let's see what adjustment we need to make. So if we write down our 5 times table, 1 times 5 is 5, 2 times 5 is 10, 15, 20, and 25. So this is our 5 times table. So this would be 5n. So this sequence here would be 5n, but we've got this sequence. So what adjustment do we have to make to go from our 5 times table to our sequence? And hopefully you can see that we are adding on 4. Go from 5 to 9, we're adding on 4. Go from 10 to 14, we're adding on 4. And for each one, we are adding on 4. So you could think about our sequence as just being shifted up by 4. It's the same as our 5 times table, but we've just shifted it up by 4. So our answer is 5n plus 4. So we've come to the end of the walkthrough for the foundation tier paper. So I hope you enjoyed that. Well, maybe you're not enjoyed, but I hope you got a lot out of it. And hopefully it will be beneficial for you when you go into your third and final maths exam. So thank you again for watching and take care. Bye-bye.